Okay, good evening, everyone. Welcome once again. So, as I've said, right, this is the CCIE DevNet Technology Bootcamp, which means we'll be covering quite a bit of technology which is involved in CCIE DevNet. So, what you would be needing to successfully complete this bootcamp is DevNet VM image with most of the things that we'll be using already pre-installed, so that you don't have to run here and there and wonder how to set it up. So the links are provided here. So we'll be getting a VM image with Python, Ansible, Docker, Terraform, most of these tools pre-installed. Now this is available as a OVA image. So to set it up, we will be needing something like a VMware workstation player. Right? Then we'll be getting in depth into Python and Ansible. So those are like kind of essential must for every network engineer. So we'll be needing some code editors or IDEs, integrated development environments, like VS Code, PyCharm, or any other editor of your choice. Again, these are available on the CWS itself, but if you prefer to, since CWS will be sitting as a VM, if you prefer to work in your local desktops or laptops, you can download them and install them and connect them to CWS. Okay, you'll be getting this guide soon after this session, so that you can download these images. I mean, we provide this image. It's basically the same thing. You can take it from either our drive or the Cisco drive. I mean, we do this because sometimes Cisco drive is, some people complain saying that they were not able to download. So we just downloaded and provided this copy. So you can take either of them. If you are taking ours, username password have been slightly changed. So these are the credentials. If you are taking Cisco's, I'll give you the credentials, Cisco's standard credentials. Okay, if you take a Cisco image, what you get is a zip file, which you need to unzip into some other folder and then open the OVA file with any of the virtualization software like VMware Workstation. So there's the link to where you can download the VMware player from, and there's the link where you can download Visual Studio Code from. Okay. Yeah, the first section is Terraform. Right. I'm not sure how many of you heard about this tool, but Terraform is classified as infrastructure as a code tool. Right. It's one of the primary components of automation. As you're going to see, this entire course, the entire concept of DevNet is centered around automation. Automate everything that you can, right? So right from the very first step in the process of automation is we'll try and automate the infrastructure provisioning itself, right? The way you create your VMs, the way you create your Docker images, the way you create some of your ACI resources, those things themselves should be automated. So that's where the infrastructure as a code tool comes into picture. Infrastructure as a code, which means you'll be writing code to create infrastructure. You'll be creating some configuration files, which will form the basis of your automation script. So that is kind of automation script, which will be taken by this tool called as Terraform, and it will simply follow those instructions. Okay, Terraform is classified as a infrastructure as a code tool. What you can do using Terraform is you can build, you can change, you can version, and you can delete, destroy the resources that you have created both on cloud and on premise safely and efficiently. Come on, guys, I'm not speaking. Few seconds, I take a break and then like no audio, no audio. You guys can't hear me? Okay. Yeah. Looks like a couple of guys are facing the um, audio issues. So not sure, I mean, how this, I, I don't know how to help you guys, but maybe you can leave the meeting and rejoin. Well, yeah, have some patience, guys. I mean, the PDF will be shared soon after this. I know, I mean, you guys are eager, but yeah, I've seen that, yeah, once you get PDF, you keep jumping here and there without focusing on the class. Well, yeah, I mean, Zoom is pretty old now. They're all used to these. Okay. Okay. So what is infrastructure, right? Anything that you provision and set up your servers, your Docker images, your ACI related resources, right? All these form your basic infrastructure. On top of it, you are going to build your further applications and do something with them, right? So we classify all these as resources, right? Anything that you try to, any piece of infrastructure, either it can be as big as a complete VM, or it can be as small as a an ACI tenant, ACI. I'm not sure how many guys are familiar with ACI, because I keep taking that example because that's used in DevNet. Even I'm not expert in ACI. So, right. So maybe we'll talk in terms of um, VMs. VMs are Docker images. Okay. So basically, you'll be creating some resources. So resources are defined in human readable configuration, right? Because we'll be writing some files to create this infrastructure as a code. The code itself should be easy to understand, easy to write, right? Um, so far, we have been staying away from programming. We have not become programmers because the programs are like typically somewhat complex, right? There's a lot of logic that goes into it, right? For various reasons, we have stayed away from programming. But uh, the DevNet, right, is trying to convert the network engineers into a decent level programmers where we are expected to write something. But still, the configuration files that we want, that we are going to write, we want them to be not very complicated. So they should be easy to write, easy to understand. If I am writing a file, someone should be able to understand what I'm trying to do there. If I take someone else's files, I should be able to find out what is happening by looking at this thing. Right? That's the way these configuration files have been designed. Right? Another advantage of putting what you want to do, right? The automation that you want to do into these configuration files is that these configuration files become like specifications, because now you are putting them in black and white, in ink or in typing letters, right? They become like your specification. Now they can be stored, they can be uploaded into your version control system. They can be shared with your team, saying that this is the specification that I followed for creating my configuration. So that can be reviewed, revised, Okay, so we are going to see what are resources and what is the human readable configuration that it is going to be in. And what is the advantage of it is we can upload them to version control systems, they can be reused, shared, and they can act as a specification. Now, what can it manage? It can manage a lot of things. Terraform can be used to manage a lot of resources, like low-level resources like your compute, storage, networking, which means we can create. Compute means in the cloud terminology, the VMs, right? Storage is like we can create disks. Networking is like we can create VNets, subnets. So these are like low-level resources. And we can also create high-level resources like you have your networking. On top of that, you can create network entries, DNS entries, um, software as a service features, etc., etc. Okay. So that's in short what Terraform is all about. So basically, you're going to build some configuration files, which in turn will help you to provision certain resources. Right. So it's like a kind of infrastructure automation tool. Right. If you want to classify, if you want to summarize what is Terraform, Terraform is an infrastructure provisioning automation tool. Installation is pretty simple. It's just a executable file. If you want to put it on Windows, we can go to Terraform website. So depending on what type of operating system you have, right, it's available for different operating systems. On Windows, it is you just download this. It is about 4 or 10 MB in size. It's just an executable file. You just put it at some location and add it to the path. You have it up and running. Right? Linux, either you can download the zip file or you can. There's a repository from where it is available. You first add its key, then you add that repository to your local, update your local repository with a link to your repository from where Terraform is available. Update your repository and you can install it. Or simply you can download the binary, again, put it at some location and just set the path to it and you can start using it. Yeah. Now you don't those instructions if you want to install on your local systems, but if you have downloaded the DevNet VM image, it's already pre-installed. So you don't have to do anything as such. So let me start up my VM. Okay, while it's starting up, yeah, so this is the link I've given. So if you have downloaded the VM, it's already installed. If you want to put it on any other system, you can go to this link and follow the instructions. Now, how does Terraform work? Right, as I said, it is just about it's a very small. Do I have it installed on my Windows? Oh, it is there. It's in work programs. Okay, it's about 60 MB in size, but still it's much less compared to, compared to the power it has, right? So it's just a executable file. But as I said, what can it do? It can do a lot. It can create, it can help you to automate creation of your cloud resources like your Azure VMs, AWS VMs, GCP VMs, then your Cisco ACI resources, your Docker resources, etc., etc., etc. Now, how does it work, right? How does this tool work? Just like any other tools, right? Terraform also, what we downloaded is just the skeleton, just the framework. But the power of Terraform comes from plugins, right? Nowadays, you take any software, it's the same as you're going to see, right? You download Python, you get your base programming language, maybe with some additional third-party libraries. But let's say you want to enhance power of Python by you want to do network automation, you will have to download network-related libraries. Same is the case with Ansible, right? You download an Ansible, you get some pre-installed tools with it. If you want to enhance on top of it, you download the plugin separately. Same is the case with Terraform. You downloaded Terraform. In fact, it is slightly different. Terraform doesn't come with any of the things pre-installed. It just comes as a skeleton. So when you download Terraform, all you get is Terraform, nothing else. But rest all the functionality of Terraform to create, let's say, Azure resources, AWS resources, Docker resources, Cisco resources, etc., etc. It's all done by these so-called plugins, or in Terraform parlance, they are called as providers. Right? Providers enable Terraform to work with virtually any platform or service with an accessible API. Right? So, which means you have Terraform core, Terraform base, then you have a bunch of providers sitting, like Azure provider, AWS provider. So Terraform, using the features provided by the providers, interacts with the underlying platform. This interaction is made possible through APIs. Now, what are APIs? API stands for Application Programming Interfaces. That is one way of two software programs talking to each other. Right? In this case, Terraform is an application, is a software application. Using this, you're trying to create cloud resources in your Azure platform. So, which is again another software application. So, for these two softwares to talk to each other, you have some interface that we call it as API, Application Programming Interface. Right? That is two software pieces talk to each other using this concept called as APIs. Now, how do we human beings interact with software applications? Using something called as GUI, right? Graphical user interface, which is nothing but a nice looking interface like a mobile app or a desktop app or a web application. Right? So we open that application, we'll be able to see a bunch of icons or buttons or text boxes. So we interact with the application by entering the data, by clicking the buttons, by clicking the links, etc. But how do two programs communicate each other? Two programs talk to each other to achieve similar thing. They use this APIs, right? So we'll be seeing what are APIs, what are the different types of APIs, how APIs work, how we can use APIs in a slightly different section. But for now, we have seen that yes, there is a core Terraform. On top of this core Terraform, we have a bunch of plugins. We call them as providers. Now, Terraform, using these providers, it goes and performs certain automation tasks on the underlying infrastructure of the platforms through the APIs. Okay. HashiCorp and the Terraform community. HashiCorp is the company which has created this tool called as Terraform. So the company itself and the Terraform community, which means a group of organizations that use Terraform actively and developers like us, right, who develop open source software. So they have already written thousands of providers to manage different types of resources. Now, what all types of resources can be managed? What is there? The library, the repository of these resources, these providers are available at this location. An online repository from where you can download these repositories. You click on this browse providers, you will get to see what all providers are there. Now, providers are nothing but just plugins. Is just the terminology that this uses. So you see the top rated ones are appeared at the top because obviously they are big companies, they have the big money. So obviously Terraform gives them the highest preference. So AWS, Azure, GCP, Kubernetes, Alibaba Cloud, Oracle Cloud Infrastructure, even Microsoft Active Directory. You can create Active Directory resources directly using Terraform. Right, so these are all the providers. Using, let's say I want to create an Azure VM, I'll be using this provider. I want to create a AWS resources, AWS VM, EC2 VM, S3 storage, or network, right, Route 53 network, etc., etc. I can create anything that I can do manually using this provider. Same is the case with other things as well. Okay, now let's search for, let's say, Docker. Right, so this is the Docker provided by this guy called as Cruise Worker, version 3.0.2. So how many times this has been downloaded this week, how many times this month, overall, right? Overall 9.4 million times this has been used. Okay. So when I want to use this provider, or when I want to, now I don't know what I can do with this, right? So first thing I'll be doing is I'll either check this documentation, or I click on this use provider. I click on this documentation, it takes me to the document. We'll come into this details later, but this is the way you can find your way around this with Terraform, right? First, you need to figure out, identify the scope, like what you plan to do with Terraform, right? What kind of resources that you're trying to automate their creation. Then go to Terraform registry, search for the available resources. Then go and check its documentation, their documentation. And then click on the use provider. You will get some information how to use this provider to achieve your task. Okay, you can explore these providers when you are doing some things. Now, this is the Terraform workflow. We first write the file, create a config file in this special language called as HCL, which stands for HashiCorp config language, HashiCorp configuration language, which defines the infrastructure in a declarative way. And declarative way means we just specify what we need without actually getting into the details of how exactly that should be procured. So we first write, and then we first check. We first create a plan, which means this is like a dry mode without actually going and creating, because we are dealing with infrastructure, right? We are dealing with the creation, modification, and destruction of infrastructure. If while creating is perfectly fine, right? If you even if you end up creating some unwanted resources, you can always delete them. But modification and destruction of existing resources can be a little dangerous, can be tricky and a little dangerous, right? If something is already being used in production, if you go and without realizing the impact of it, if you go and modify something, or if you delete something, you end up causing outages, right? So we should be a little careful. That's why these guys have provided something called as a plan, which will show you what it is going to do. The instructions that you put in this HashiCorp config language file, what is the impact that is going to have on the backend, that will be clearly highlighted in this plan. If you're satisfied with the plan, then we'll go ahead and apply that plan. Right? So this will ask us to confirm yes or no. Once we say yes or no, it will go ahead and make those changes. So you should be doubly sure what you're doing. Okay. So before going into these things, we'll just see, do a little bit of hands-on. So I have the way I set up my environment is I have this VMware workstation. Right? If you have, if you don't have workstation, you can always the link, you can download the VMware player, the link for which is there in the document, and you'll be downloading the OVA image from where the link for which I've given in the document again. Then we'll be creating new virtual machine and pointing it to that OVA, the image which is there in the OVA. You will have this guy up and running. Then I started it. Now there are two ways. Either I can go inside and connect to it, or I've set up a remote connectivity from my system via SSH. Right? Why I have done that is so that I can use this editor called as VS Code, which is a beautiful piece of given to us by Microsoft guys. So this is very, very, very powerful. Right? This is called as Visual Studio Code. It is very powerful, but again, it's when you download it, it's like a basic editor. Its power comes from plugins. So this, if you click here, you will see all the plugins which are available, what have been installed, what have been recommended, what are available. You can always search, go and search here. Right, so you can download this, and yeah, one useful plugin that you would like to have is remote SSH. I'll give you the plugin name. It comes as a group of plugins. Right? Why this is required is it will give you this small icon that you see here, right? Where you can open a remote machine. You click here. It will give you some options, right? So you can connect to something called as WSL. WSL stands for Windows Subsystem for Linux. On Windows machine, you can set up a Linux environment. Right? WSL instruction. You can check out the WSL instructions on Microsoft's website. If you have a recent desktop or laptop with recent version of Windows, setting up WSL is very easy. It's just one command, WSL -- install, and it's up and it is set up, and you can download any of the Linux flavors from your store, Microsoft Store. And you have different flavors of Ubuntu which are provided to you. So once you set up WSL, you can install any of these, and you also have other flavors of Linux. You have Kali Linux. Right? If you're trying to become a ethical hacker, you can download Kali Linux and explore all its vulnerabilities. And so that's WSL. Otherwise, what I've done, yeah, what I've done is I've set up my SSH connectivity to my remote system. If you're familiar with it, well and good. Otherwise, I can always guide you and let me know in the probably I'll update the as a prerequisite section in the guide. Okay, there is my config file. Connect to host. Connect to new dev. This is the option to open config file. Connect to, yeah, when I say connect to host, it will say, it will show me if I've configured any remote host or it will tell me configure SSH host. So this is the file where I've configured a bunch of hosts. So this is where this is the IP address of my machine, username. I've created an SSH keys. So this is my identity file. So by putting these details into the config SSH config file, I'll be able to directly connect to this. So because of these entries, Azure, Ubuntu, and DevNet CWS are mentioned in this, when I click on connect to host, I'll be able to see these two entries. So in this, I want to connect, let's say, DevNet CWS. So it opens up by pointing to my remote host. So I'll be able to see the folders which are there on my remote host. Where I'll be landing, I connected as a user expert, so I'll be landing in experts home directory. Okay. When I say open folder, it shows me that yes, I'm here currently, home/expert, because I connected as expert, user expert. It's a Visual Studio Code. There's a primary difference between Ansible and Terraform. For instance, you cannot create VMs with Ansible, right? And you can configure them, but you cannot create them. So while there are some overlapping between these tools, their primary purpose is different. Infrastructure, as the name says, right? Terraform is an infrastructure as a code, which means initial provisioning is done using your Terraform. Ansible is known as configuration automation tool, right? The configuration task that you'll be doing after you provision the infrastructure. So there are some overlapping areas, right? Like yeah. So there are overlapping areas, but the very purpose is same. The initial provisioning is usually done using Terraform, and the later for the configuration task, you use Ansible. Now, for instance, the things that you can do with Ansible, you cannot do with this. Like Ansible supports things like you can copy content to files, you can copy one file from the other. And those kind of things cannot be done here. Okay, so this is this thing. So I normally go to work. Right, so what I've done here is I've connected to my CWS system from my Visual Studio Code. See, I can do these things directly also by going here, right? By connecting, let's say, as a different user. Okay, I'll SSH from outside. CD work, Terraform, right? I have the folder which I just created. CD Docker. Right? I have the file that I've created. Nano main.pm. And I'll be able to do from this editor also, but this is much more user-friendly. Moreover, you see, it has detected that I'm trying to do something with Terraform. It has changed this icon to this because the Terraform plugin has been installed, right? So here I can go and I can look for Terraform plugin, which is already, okay, I need to install it. This differs from, in my local version, it is installed. Here I need to, no, I will not take this, guys. I'll take IaC Corps. So it is saying in local, it has been installed. Do you want to install in SSH also, right? It's up to you if you want to install in both the places. But yeah, because the plugin is able to identify, it is showing this icon. So how this is helpful is it has this IntelliSense, right? When you start typing, it will keep prompting you whenever it knows what you're typing. I mean, what you intend to type, right? So it makes your life a little easier by helping you to create these files faster. Okay, so as we said, the workflow starts with writing your file. So what do we want to put in, right? We don't know because it's a new tool. We have to rely on documentation. So we go to Terraform tutorials. For starters, we are starting with Docker. Now, if you don't know what is Docker, for now you can ignore, right? You can just think of it as like some magic happening. Now, what is the magic that is happening? What exactly is happening in the background? We'll be covering this section in the Docker section. Right? Dockers are basically, you can think of them, right? I'll be like a very crude comparison, but later I'll correct myself. Right? You can think of them as like miniature VMs, right? Which can just be up and running and give you show you the applications which are running inside those VMs. Okay, so let's say I'll go on build infrastructure. Right. So that's the purpose of using this, right? For building the infrastructure, for changing the infrastructure, and for destroying the infrastructure. Now, why would you want to destroy? Because most of the times we'll be procuring infrastructure on the cloud, and the cloud resources are obviously your organizations will be having some things like you pay as you go or pay for as much as you use. So when you are done with, let's say, a short-term projects, you don't want to keep them. Anyway, you have your files. You would want to destroy the infrastructure to cut down on the costs. But then you might ask, okay, tomorrow, what if a similar project from a different project, different customer comes? Anyway, you have your infrastructure as code files stored in your repositories, right? You just use the file to spin up new set of infrastructure machines, and you use your tools like Ansible to configure them. So within matter of, let's say, an hour or so, you have your complete infrastructure up and running again with the configuration, right? So these two tools, Terraform and Ansible, they complement each other. So you provision the devices with Terraform, you configure them using your Ansible. So um, this can speed up your, let's say, DR kind of activity in case of disaster recovery kind of thing. Your data is been backed up in your databases through the database backup mechanisms. But what about the environment on which the data has to be hosted, right? So that's where these tools come into picture. Using your pre-written IaC files, Terraform manifest files, you can quickly procure the servers using the Ansible playbooks. We call the Ansible scripts as playbooks. We'll be revisiting them later. So using Ansible, you can run those playbooks and complete the configuration on the servers that you have provided. So, and you quickly have your infrastructure up and running as it was before the disaster has occurred. So we'll be seeing that use case anyway. So, but this is the way you start writing, right? First, you need to tell Terraform which provider you want to use. As I said, Terraform comes like a blank box, right? It doesn't come with any pre-installed stuff. So you need to tell what you intend to use. So you are clearly giving this path. Now this path is the path of this resource on the registry, on the Terraform registry, on the website, right? And which version of that particular provider you intend to use. So this is like greater than or equal to 3.0.1, right? So this is the name that you're referring. Right? So we are indirectly telling Terraform to go to this location and fetch the Docker and fetch this provider and save it locally with the name Docker. Then you are telling further, going ahead, you are telling this is the provider. The provider which I've procured above is the one which is to be used for all the tasks that I'm going to go do further. Right? If you're wondering what is this syntax, what is this language, I think we already discussed this, right? This is what is HCL, HashiCorp Configuration Language. Some of you who are familiar with JSON might see somewhat, so this is somewhat similar to JSON, except that in JSON we use colons, here we use equality symbol. So there are slight differences. I don't know why these people, instead of using standardized things like JSON or YAML, they tend to use their own structures. But yes, we can, because of this familiarity with other things, we can quickly get familiar with them and start using them, right? So Terraform is like inside that we'll be creating some complex elements. So we start with a curly brace, then required providers also contains some things inside. So we start with a curly brace. Then we are trying to define this thing called as Docker. So we say equal to, again, there's a complex element because there are two things inside. So we start this curly brace. Now, what defines this required provider is a source from on the registry where it is available and a version. Right? That's the way you write these blocks, Terraform blocks. Right? So this entire file will be saved with an extension .tf. Okay. So we specified what are the required providers. We said, okay, when we initialize that this provider will be downloaded and kept locally, from then onwards, locally it is available with this name, Docker. I can start using this Docker. Now, this Docker provider will have certain type of resources that it can create, right? If you want to check, Terraform Docker. Right here, you see when in the documentation, there's a section called as resources, which means what are the different types of resources you can create using Terraform? What are the different types of Docker resources you can create using Terraform? right? Now, there are a lot for people who are not familiar with Docker. For now, I'll just talk about image and container, right? Now, this image, you are familiar with virtual machines, right? So Docker image is like a virtual machine template. Docker container is like a virtual machine, running instance of a virtual machine. For now, just understand this much. That is enough. We can go ahead, and later we'll be getting into the details, right? So we found out the provider that we want to use on the Docker documentation. We checked what are the resources that it supports. Now I want to create as I said, in comparison, a mini VM using Docker image and a mini running instance of mini VM template called as Docker image, mini running VM called as Docker container. Right. So accordingly, we start with this, right? Specify this resource and specify what is the type of resource. So this name should be one of this, and the name of the resource that you are creating, the type of the resource, right? This represents the type of the resource. The type of the resource that you are creating should be one of these. So now we are trying to create, let's say, Docker image, which is like a VM template. So resource Docker image. What is the VM template that you are trying to create? Ubuntu VM. Right? Name. This name is on the, again, Docker has like an online registry. So there are predefined templates which have been uploaded. So from that predefined list of templates, you are trying to get a template called as Ubuntu, who's with its latest version. So you are trying to get the latest version of Ubuntu template. Okay. So resource, what is the type of resource? The local name that you want to call that resource with, and from where to what exactly this resource points to. Okay. Then from this, so as I said, this will get the static image, static Ubuntu image, or like a VM template into your local system where you run this command. From that, you want to create a VM or Docker container, right? So this part does that. So resource, the type of the resource is called as Docker container. You want to give a local name to it called as FOO. And now, just like how you create a VM instance based on a VM image, you create a Docker container based on a Docker image, right? Now, which Docker image you want to refer to? This Docker image which you have created before. How do you refer to it? By using a fully qualified kind of name, right? The type of the image, dot the local name, dot some unique ID which will be assigned to it after this resource has been created, and that is called as image underscore ID. So this says that yes, I want to create this container from this image, and when the container is created, I want to call it with this name. Okay, so this will help you to get the image and create its container, get the template and create a VM from it. Resource are the elements, right? Resources are like, in this case, Docker image is a resource, container is a resource, volume is a resource, network is a resource. Registry is a collection of providers. Registry is like an online repository where all these resources are uploaded. And there's the difference between registry and resource. Okay, so either you can type it or you can copy this code and put it in your save it. You see, I don't have the Terraform plugin installed in my remote, right? So it is showing me in all white. So if I install it in resource, it will show me nice color coding. Let me go ahead and install that. It's been installed. Yeah, you get this nice color. And you also get, I start typing Terra. It says, oh, okay, you want to type Terraform. Okay. So I hit tab. It automatically completed my closing and opening brackets. And so that is, we call it as IntelliSense. Right. I'll show you how fast typing this will be using that. So I'll say Terra. Then I'll say required providers. Right. Docker source. Then I put some source there and version. Right. So I come here, copy source and version. And then I want to call that provider Docker. So it's all being done with tabs. Then I'll start creating my resources. Docker image. Of course, it won't know. It cannot go into this provider and then find out, right? It knows that these are all what it prompted are all Terraform keywords. So it is able to prompt them because we have installed Terraform plugin. So the other things it will not be able to. So we want a Docker image. Locally, we want to call it as Ubuntu. Then what is it required? Name, which points to the the name of the template from wherever it is available. Ubuntu latest. Then the second resource that you want to create is a Docker underscore container. Locally, you want to call it as my Ubuntu, let's say, right? And this requires an image. Image will be Docker image dot Ubuntu dot, right? This dot. After this image is created, we'll get an image underscore ID. And the name that you want to give to your Ubuntu container, my underscore Ubuntu underscore container, let's say. So you see that fast it is with the help of the plugin. Right? Let's go ahead and run this. Now, running this can, I mean, for most of the programming languages, we can run the code from within this editor itself. So that's why we call this as IDE, Integrated Development Environment. When you are doing the development of something, you write some code, you want to test it, you want to see it executing. So you have to go out again, come back, make some changes. So instead of doing that every time, going out and then doing that, most of the programming languages, supported programming languages, provide their interpreters or compilers from within this itself so that you can run the code from this itself. But these are tools which are not at like that advanced like programming languages. So we'll have to go out. So this is where we are. Right. So now my main.tf is complete and my Terraform is installed. Oh, it's not there. Terraform is not there. So let me good. This yeah, I thought it was there. It should have been there. How come Terraform is not there in this? I'm in main. Okay, anyway, it's just Either we can do this or we can do those 2-3 steps. Docker image. Docker is the name which we are giving. Docker image is the type of the resource that is defined by the provider. Docker container is also the type of the resource that is defined by the provider, right? You see here in this providers resources section. So these are the names that come from that. This name is what we have given, so that I can link this. Normally, we give this. I can always change this name. I can call this as Docker123 and say provider Docker123. But I would like to keep the name as this because my resources are going to be named such a way that the name of the provider underscore the type of the image. Right? So this makes it more intuitive. I'm calling my provider as Docker. Then my resources are named as Docker image, Docker container. Okay. So even if I change this name to, let's say, Docker XYZ, here I'll use Docker XYZ, but here it should still be like Docker underscore image because the resources are named within the provider with these names. Yeah, I'll just take these commands. Normally, when you're downloading something, right, we are not sure whether it's a safe place from where we are downloading. So we normally download these keys. We call them as GPG keys. So we are downloading from the HashiCorp's location. We are downloading and putting it in our local system. That's normally this will be the process. First, download the keys, add it to your repository, then add the repository to your local list of repositories, and finally you update and install. So it is not yet completed. It's been a while I updated my repositories. Done. Okay, I have the latest version and I have my file, right? So first thing that we want to do is Terraform init, right? I'll show you ls, right? ls minus a. All we have is this main.tf. Now in this, we have specified what is the provider that we need. Now I'm saying Terraform. So all the commands start with Terraform. Terraform is the executable, which understands your commands and sends them to the background. First step is initializing, which means downloading the provider and installing it in locally. So it has gone to that location. It is fetching. So yeah, it's completed. Okay, now if you do ls -a, you'll see this hidden folder and a log file. And this log file is like which will log the versions, because these are all version is very important. When you are working with one version now, later suddenly automatically the version changes, there will be a problem. So it will log the stuff. But this hidden folder, inside this hidden folder, it places this ls.terraform /providers / so it's with this created folder with this /a Docker version flavor, right? It is this binary file that will do all the magic, like all those commands that we have seen, Docker underscore image, Docker underscore container, they all are understood by this guy, and it knows how to interact with the underlying Docker, this thing, and create the images. By the way, in my local, I'm trying to do something with the Docker stuff, so Docker should be installed here. Yes, it is. And do I already have any templates? Yes, I have some, but I don't have Ubuntu. So I'm ready to run. I'll say next one is Terraform validating, right? Whether you have made any mistakes while writing your file. Say validate. Right? It says there is some invalid reference to my container in line 20. Right. So let's go to our line 20. It should be in quotes. Okay, because if I don't give in quotes, it thinks it is I'm referring to some object like this I'm using without the quotes, right? It thinks that was the mistake I made. So go and revalidate. No errors. Now I'm ready to check what my script is going to do. Terraform plan. Right? It generated the plan. As part of this plan, it is going to create. What is it going to create? A container with these properties and an image. Right? Docker image Ubuntu will be created with this. Right? You see, we just gave name, which is like mandatory. After applying, after creating, this resource will get an ID, will get an image underscore ID. This image underscore ID is what we have used here. Right? Once this image is created, as per this plan, it gets an image underscore ID after it is created. That is what we are using here. While creating container, we are referring to this its parent resource. So in this unique ID. And these things we'll get from either we need to check the plan, or we'll get from documentation. Okay, so we are happy with this. One container, one image will be created, one template will be created, and one its running instance will be created from that. So Docker images. Currently, I don't have that image with me. And Docker PS will show me the running instances. I don't have anything. Docker PS -a will show all. So there were some few past instances of MySQL, Nginx. Nginx is like a web server, and Python, but nothing related to Ubuntu. So I'll say Terraform apply. And we check the plan. We are happy with it. We say apply. I mean, again, it shows the plan and then says, do you agree? I'll say yes. So it is actually creating the resources. Okay, container exited immediately. I need to add some sleep kind of thing. But let's check. Docker images. Right now my image has been created, but no containers because it gave an error. Right. So to rectify that error, I'll add a sleep command. Right? I mean, I know to do this because I've already faced this and I know, but otherwise, normally what we do, the process that we follow is, you see, we are getting this, we got this error here. And where did it go? Oh no. Okay. Let me. Okay. So normally we take this error, go to Google obviously, and there are places like Stack Overflow where people got similar errors and they will help us out. So like that, I came to know I need to add some sleep. So the way to add sleep is we give a command sleep and how long to sleep in milliseconds. So let's say just half a second is enough, and in milliseconds. Yeah, now it has been created. So you see, it is saying only one has been added because one image has already been created. It just created the container now. So like that, it of images of yes, it will show my Ubuntu container is created. Okay, now the same thing can be done with a single command like docker pull Ubuntu. So you might ask, okay, what big deal this is doing? But imagine it's like, I mean, you have a script, like you can run it. Moreover, like this is just a simple one. But when we create some complex images like cloud VMs, Azure VMs, or AWS VMs, where there are a lot of parameters which we need to specify. Doing this manually, somewhere some parameters can get missed out, and we can end up with inconsistent resources. So, like if you have created 10 VMs manually, the configuration might be different on all those machines, and depending on your state of mind, how tired or how irritated you are at that point of time. But the script will never make a mistake. You create it once, thoroughly check it, test it, and then store it. That's it. It will keep doing the same things again and again and again with the same configuration. Okay, that's in general the power of automation. Yeah, that's what. Yeah. Now, how do we change infra? Right? Let's say we'll go to Docker Hub and see what are the other Docker Hub. Docker Hub is like just like the HashiCorp registry that we have seen. Docker Hub is the place where you can find pre-created Docker images. Right. That I'll go to Ubuntu. So what I've taken, right? If I simply say Docker pull Ubuntu, it pulls the latest one. But what are the other versions that are available? We call them as tags. Right? This is latest. This is what we have used. But there are things like rolling, Mantic, Lunar, Jammy. Jammies are that 22.04. Okay. Devil, let's say 23.10. So I don't want latest. I want, let's say 23.10. So what I'll do, since I've created my infrastructure using Terraform, I'll use Terraform itself to modify my infrastructure. I'll say, I don't want latest, I want 23.10. Okay. I'll go and reapply. Terraform, apply. So it is saying Docker Ubuntu container must be replaced, right? And Docker Ubuntu image, Docker image Ubuntu must be replaced because our desired state. So this file that we are looking at, right? This file that we are looking at defines the desired state of our infrastructure. What is my desire is to have Ubuntu image of version 23.10 and a container to be created from that. But what we have there is latest Ubuntu image and the container created from it. So what I have is different from what I want. So Terraform is going to ensure. Initially what happened? I didn't have anything, right? When I had this latest here, what I wanted latest version of Ubuntu and its container to be created. What was there actually? Nothing was there. Ubuntu image was not there. Its container was not there. So my desired state and my actual state were not matching. So it went ahead and created. Now my desired state has changed. I don't want the latest. I want little older one to be there. But what is there in actual? The latest one. So it must replace, right? So that's what it is saying. So it must replace the existing version with the new version. So we'll say, yes, go ahead. So it is destroying the existing one and creating the new ones. Okay. Done. CLS, Docker, images. You see, now I have Ubuntu 23.10. Now the latest one. Same with container as well. Of course, you won't be able to make out from here. It's Docker inspect. Somewhere the name will be there, the image that I've used. Anyway, okay. Now let's say I'm done using this whatever the image container, etc., etc. I want to save costs. I want to shut them down. I want to destroy for some reason. Okay. So I'll simply say Terraform destroy. So it says it's going to, here it gives the plan, right? 0 to add, 0 to change, 2 to destroy. Previously it was like 0 to add, 2 to change, 0 to destroy. Initially it was 2 to create, 0 to change, 0 to destroy. So now it is time for destruction. It says, okay, if you say yes, I'll go ahead and destroy whatever I've created. Okay. Yes, go ahead and delete. It got rid of the resources. Docker images will not show the Ubuntu image. Docker PS will not show. Right? Even PS minus A, which is like past exited containers, also will not be shown because it will be completely removed from the system. Okay, so that's what Write, plan, apply. Resource blocks are those that we have seen, starting with the keyword resource, right? Resources are the most important elements. Now you will be able to appreciate when you revisit this document. Resources are the most important elements in Terraform language. Each resource block describes one or more infrastructure objects, such as virtual networks, compute instances, high-level DNS records. In the example that we have seen, Docker images and containers. Syntax to be followed. Right, a resource block declares a resource. We discussed this in detail. Right, local name. So we define a type, we give a local name to it. Then concept of providers, we have seen in length what are providers, and this is the place where you can get all the providers from. This is the sample example that we have taken. So here I'm creating a different. So there I have created Ubuntu. Here Nginx is like a web server. Okay, so I write a file. Since we are talking about a web server, we need to do something called as a port mapping, which means in the container, your web server, Nginx web server, will be running at port 80. Since I can't access the container directly, I'll map it to port 8000 on the host, that is on the machine where I'm installing this. So after this is installed, I'll access it using localhost :8000, which will show me what is there, what is running in the container. Okay, Terraform init, Terraform plan, Terraform apply. Once you're done with your work, Terraform destroy if you wish to. Okay. Now, you see, ls, right? It has created something like terraform.tf state. Right? So when we said create, after that, when we said modify, how did it know like what it has created, what it has to modify? And when we said destroy, it should destroy only the things which it has created, right? Because I had Docker images. I had these other images, right? It didn't touch the other images. It deleted, it changed and deleted only that image which it has created. Right? How did it know? All that information it maintains in this file called as state file, right? Terraform.tf state. Here it keeps track of all the resources that it has created when those are created. Okay, so that it won't fiddle around with the other resources which are there already in the system. So if you want to have a look at the Terraform TF state, we can open it from here. It's just since we deleted, it's all blank, right? Again, it is back to the original state, but this backup file shows that the previous stuff, all the resources that it has created. Right? Docker image called as Ubuntu has been created using this provider with these attributes, and it had created this container called my Ubuntu container. So it is maintaining the complete track of the resources that it has created. Now, since I destroyed them, it moved that current state to backup and it cleaned up the state. Okay, this is how it is able to keep track of the resources that it is working with. Okay, so we'll stop here. This will be your hands-on. Create an Nginx container. Code has already been given. Right, I've given that expose on port 8000. So initially you expose this on port 8000. After this, if you access localhost your machine, whichever on machine you install, if that machine IP :8000, you should see one Nginx welcome page. Then change this port to something like 8088, rerun. So it should modify your application. It should destroy your existing application existing these things and redeploy stuff so that now your new server will be available on the change port 8088 or something. Then after verifying, you can go ahead and destroy. Okay, we'll discuss these things later. What are variables, etc., etc.